Okay, welcome back. I hope that your mid-unit assessment went well, and now we're back into our second half or second part of our Unit 4. And so we're actually going to switch gears a little bit. We were talking about representing functions through function notation and graphs and things like that. And moving forward past the mid-unit, we're going to start looking at other characteristics of our functions and really start to put everything that we've been learning together. And so that is really the objective over the rest of the unit. We'll be talking a little bit about specific types of functions too, like absolute value functions and piecewise functions, and we'll be getting to that towards the end of our unit. And so a super important part of our first lesson after our unit is our discussion about what is the domain and range of a function. And so I actually gave you the definitions this time because I'm going to be using those two words a lot in this video. So I wanted to make sure we were all on the same page as I'm describing what is going on. And so our learning objective for today is when I give a description of a function in a situation, I can determine the reasonable domain and range for the function. Domain is the set of all possible input values, and the range is a set of all possible output values. And we'll describe what does that represent and what does that look like with a graph or with a description as we go along. And so let's go back to a scenario we've seen before, describing the total number of times a dog has barked as a function of time in seconds after its owner was tied to a leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away from the dog. And so here is our scenario. We have our input value and our output value, and we can use that to help us determine our range. And so if we're being very specific, let's look first. All right, we saw a situation as the number of times the dog has barked as a function of time in seconds. The owner tied his leash to a post and left. Less than 3 minutes after he left, the owner was returned and tied the leash and walked away with the dog. So I know that these all relate to my input values. My input is a input of time. On the other hand, I'm looking for my output. My output is the total number of times the dog has barked as a function of our time. You look at the time, and I know that at 2:13, the dog has barked 14 times, right? I can use that to help me create my situation, right? The number of times the dog has barked depends on my time. And so the question is, what are reasonable values for my inputs and outputs? Which, right, this entire situation is a start of what is my domain and my range. And so what values can be inputs of my function? And I know my input, remember, is my time in seconds. So I know that 15 can be input because the dog, we can measure 15 seconds. I know that there can be 84 and a half seconds, which absolutely, which makes sense because you can still have half a second. We don't usually measure in half seconds, but something we can still do. 300 could be a reasonable time because you can have 300 seconds. But one thing you want to think about is that, does that make sense in every part of my situation? So I also know that even though it represents my time in seconds, less than 3 minutes after the owner returned. And so if we want to determine, right, how many seconds are in a minute, we would do our 300 divided by 60, which tells me 300 represents 5 minutes. And so this cannot be a reasonable input to our function because less than 3, if I look at 5 minutes, we don't know how many times the dog has barked because the owner already took him away. And so that cannot be a reasonable input for my function. On the other hand, we can look at our different outputs values. And so my output here represents the total number of times the dog has barked. And so I want you to take a look at those 3 scenarios and say, okay, can the dog bark 15 times? Can the dog bark 84 and a half times? Can the dog bark 300 times? And think about why that may or may not make sense. And so you'll be practicing this with a bunch of scenarios moving forward, right? In this case, we have an area of a square. in centimeters is a function of its side length in centimeters, right? So my input is my side length, and I'll keep it in red because I'll try to keep it consistent. My input here is my side length, and my output is my area of the square in centimeters. And so how can we use that to help me determine what are possible input values, input being my side length here. So what are some possible inputs and what are some impossible inputs? And something that might be helpful for you to draw is that square, and can I measure side length when I have a decimal, when I have a negative, when I have a whole number, and things like that. So use that to start off your exploration on what does it mean to have an input and an output. And you're going to do that for this scenario and this scenario as well. So only input values, not anything to do with our output values at all. And so now we're going to transition into our output values. And so this represents the scenario I was saying before, right? We have our side length in centimeters as our input, as our x values, and we have our area of our square as our y values. And so don't forget on the sketch, mark 3 points that are input-output pairs of this function. This can also help you in your, while you are doing your card sort right before this. And so I know that one input-output pair is 4.5 and 20, right? I can choose this point here. This is 4.5 and 20. And so we can determine 3 other input and output pairs as part of our function. You can write it in function notation if that's, excuse me, more helpful for you. A of 4.5 gives me 20, or you can write it as your coordinate points. Either way is acceptable for me. And so now you want to describe how what each of these scenarios represent, right? We know that the possible input values is any number greater than or equal to 0, right? We can see that all of these numbers are greater than or equal to 0. And how can we do the same for our output values, right? Our output values is our y-axis. So what are all the output values as part of our area? And what does area represent? You can think about that in context as well. And so I want you to continue that same idea for going through function r as well. Like, what are possible outputs of my function when I have n is a number of campers and r is defined by this function. And so remember, our output is our camp revenue. If you need to go back to read this entire scenario again, that is also an option as well. So this slide relates to the scenario before. Think about what a proper graph would look like and describe all the sets of possible outputs of R. And so you want to continue to follow that same trend over the next couple of slides, right? We're just doing some more practice when it comes to how can I determine my inputs and my output values. For example, as you can see here, something looks really odd here, right? This function is not connected to each other. It kind of just like drops off somewhere. And I want you to explore this, right? This slide is a bit of an exploration for you, right? My domain, as always, is my x values. And so what happens, oops, sorry. Let me click out. What happens with my x-axis? Does every value work? And you can see that with your function as well. So at each point, you can look at the graph, or you can substitute in those values, right? If I want to do 6 divided by replacing our x, 10 minus 2, this will give me 0.75. I can also substitute that value in to get my output, and this gives me 0 minus 2. This gives me a value of -3, and try each of these values and see what is happening. And you can match that up on the graph as well by looking at -10, and I know that is -0.5. And so looking at that graph and seeing what the relationship is between our table and what is actually happening in our graph. So substitute those values in, and I forgot my negative, and that's why the numbers didn't match up. There we go. And look at what is happening at each scenario and determine from there, right? This slide is a bit of an exploration. Fill out the table, look at the graph, and talk about what you notice and how that changes the domain or the input values of our function. And I'll give you a hint. The denominator is a huge tell sign. So look at the denominator and see what's going to happen. Last but not least, you're looking at the time on a swing of a child who is swinging for 30 seconds and gets off the swing. The function h is the height of the swing in feet as a function of time, since the child gets on the swing is graphed to the left. So see if you can use all of that information, as well as especially the new information below, to label the axes and give yourself more information. And finally, describe your domain and range below. So I know that can time be negative and things like that. So start using what you know in your own situation, but also in general to help you figure it out. And so if any part of that was confusing, you have both lesson 10 and lesson 11 summaries that will hopefully be helpful to clear up any information, or if you're stuck on what a domain and a range represents. So I will see you in lesson 12.